All right, here we are at the warm-up, and this asks us to fill out the table so that it represents the graph. And so what we notice here is that our x values are given here in the table, and we need to fill out the y values. So when x is 1, what is the y value? So here x is 1. Right there, that is where we're talking about. So I'm going to put a little dot there so it's the same color as the table. So we can see that when x is 1, y is 4. So I'm going to fill in a 4 there for the y value where x is 1. When x is 2, there's the line. When x is 2, y is 6. When x is 3, y is 6 isn't right. How come no one called me on that? 6, 7. When x is 3, y is 10. When x is 4, y is 13. And right up here in the corner, you might guess that it's 16. It kind of looks like that's where it is. But we can also see that in the table, we are adding 3 each time as our x values increase by 1, which would mean our y value has to be 16. Questions on that table? What is the growth rate or slope of the line? Well, because we can see that it in the table, it increases by 3 as the x values increase by 1, and that continues to happen here and here. We can also see that when we go to the right 1 unit, so that's our delta x, we've talked about that, that's a change in x of 1. And I'm going to actually make that a dotted line there. It makes it a little more clear so it doesn't get confused with the actual line itself. We go up 3 units. And so that also shows us that our growth rate is 3, or the slope is 3. Questions about the table or the slope at this time? And we can see that that keeps changing by the same amount. The y-intercept is the point where the line crosses the y-axis. So what is the y-intercept? So here is the y-axis. The place where that line crosses the y-axis is right here at that point. And that point is the point 0, the x value is 0, 1, the y value is 1. So the y-intercept of the line is 1, 0, 1. It's a point. Are there any questions on the warm-up there? Any parts of it? All right, we're going to take a pause. All right, so in this slide, we're looking at a pattern and a graph, and we're focusing on how they match up. So this is, you can think of this as figure 1, figure 2, figure 3. All right, so that's what you can think of it as. And so we see that here in figure 1, how many tiles are there in figure 1? You can say it, you can type it in the chat. You could just turn on your mic and just blurt it out. It'll be great. 4. There are 4 tiles. Yeah. 1, 2, 3, 4. And what do you think why are these ones red in figure 2? Why are they red? Yeah, Elisha. We've added them, yeah. So we can see that there are 3 more there. So that's a total of 7. And then in figure 3, again, we've added 3. So we have 10. That's right, Elliot. Thank you. So what we can see is that when x is 1, the y value is 4. The y value is 4. So here we have the point 1, 4. You can see it right there on the graph. 1, 4. And I'm going to change the colors on these just so that they're a little bit more obvious. So on the next one, we have when in figure 2, so when x is 2, there are 7 tiles. So when x is 2, y is 7. And the other thing that we can see is that when we move from figure 1 to figure 2, so we go to the right 1 unit, we go up 3. So when we go to the right 1, we go up 3. And I did that in red because those are how many, as we go from figure 1 to figure 2, we add 3 tiles. So as we go from figure 1 to figure 2, we add 3 tiles. And now down here, I'm going to recolor that one. Let's do it in green. That looks good. And so in figure 3, we have 10 tiles. So when the x value is 3, the y value is 10. And again, we can see that when we move to the right 1 unit, we go up 3 units. Saying the same thing, when we increase the figure number by 1, we increase the number of tiles by 3. So x is the figure number, and y is the number of tiles. Okay? And the slope can be seen as how many tiles we are increasing by each time we increase the figure number by 1. It is important. Well, we'll talk about that later. All right. Any questions here before we go on? All right. Now in the table, again, let me see. We went blue, orange, green. All right. So in the table, we can put our x and y values in. When x is 1, that is the figure number is 1, the y value is 4. When x is 2, the y value is 7. The number of tiles is 7. When x is 3, the figure number is 3. The number of tiles is 10. The y value is 10. And this pattern continues on. We can see that as the x value, or the figure number, increases by 1, the y value, or the number of tiles, increases by 3. And that will continue on. So we can fill in the table. We know that as x increases by 1, so goes from 3 to 4, y will increase by 3, go from 10 to 13. As x increases by 1, the figure number goes from 4 to 5. The y value, the number of tiles, will increase by 3, going from 13 to 16. Any questions on the table? Now, the next thing we're going to talk about is solution of the equation or solution to the equation. But first, we need to have an equation. And I'm going to tell you what the equation here is, unless someone knows. Does anyone know what the equation will be? Or want to guess? Or know even a part of it? Elisha, you want to give it a shot? Yeah. So be careful there. So one thing is y is equal to 3x plus 1. Elliot, you said hold on. Were you thinking about it? Yeah. All right. Do Elisha or Elliot, does one of you want to tell me where does this 3 come from? You were going to say the same thing. Awesome. What's that 3 represent in the equation? Think about the table. Think about the pattern. Is the 3 in the pattern or the table, Elisha? Yeah, so what I think you're saying is that this 3 is this 3. We're adding 3 in our y values each time. We're adding 3 tiles each time. So that 3 is the same. Now this 1, that's a little bit more confusing. Elisha, you knew it was 1. And Elliot, yep, because you're adding 3 per figure number on the as we increase the figure number by 1, we're increasing the y value by 3. Yep. So where did this 1 come from, Elisha? Or anybody else? Elisha, did you want to answer? Yeah. Okay. Okay. All right. So you're saying that are you saying that we would have to go up like that? No. Yeah. All right. So where does that 1 come from? Well, we'll talk about that more later. But for right now, this is our equation. And when we think about a solution to the equation, here is what we mean. We can take any xy pair, a coordinate point, and plug it in for x and y, and the equation will come out to be true. So here, our y value is 4, so I'll plug 4 in for y. It's equal to 3 times our x value is 1, and then plus 1. So now, on the right-hand side, 3 times 1 is 3, plus 1, 4 equals 4, and that checks. I'm going to show you another point. We can pick any point. Does anyone have a particular point they like? Let's do 310. All right, so the y value is 10 is equal to 3 times the x value is 3. So I'm using this point right here, 310, and I'm plugging it in. And then we have to add 1 here at the end because of this plus 1. So notice I just plugged 3 in for x, and I plugged 10 in for y. Guess I could have put in a little break right here to say this is an example here. It's separated off from the equation itself, and this is another example. So on the right, 3 times 3 is 9, and then we have plus 1. And then 9 plus 1 is 10, so 10 equals 10. So a solution to an equation is a point that makes the equation true. And 413 would work as well, Elliot. Yep, 413 right here. Any XY pair that would show up in the pattern would make the equation true. And it would also be a point on our graph. So that's how the pattern, points, coordinates, and solutions and tables all work together. All right. Any questions there? All right, we're going to pause the video right here. All right, so the slope-intercept form of linear equations is the most commonly used form, and it's y equals mx plus b. So the slope is the m that's in front of the x. And when we talk about slope, we talk about rise over run. And another way of thinking of that is change in x, that's the rise, the change in x, over change in y, that's the run. And we represent that mathematically as delta y. Oh, I just did that backwards. No one said anything even. Change in y over change in x. So rise is change in y, run is change in x. So we have delta y, that means change in y, over delta x, change in x. So this delta just means change in. It's a Greek letter that we use in math to shorten. We don't have to write out change in. And there's another way to do that, and I'm not going to focus on it today. There's going to be something else that we add here next class. The y-intercept is in the equation, the y-intercept is the b value here. So the y-intercept is the place where the line crosses the y-axis, the point where the line crosses the y-axis. And what's always true at those is that x is equal to 0. So x is always equal to 0 at y-intercepts. So the point would be like 0, b. That would be the y-intercept. The independent variable is x. And we usually think of that as the input. And it is the horizontal variable on a graph. The dependent variable is the variable, y. And that is the output or the vertical variable on a graph. Okay? So that is the slope-intercept form of the equation. Slope, rise over run, y-intercept. This is why it is called slope intercept form. Questions? All right. So now we're going to talk about fractions and slope. Elisha, did you have something there? Okay. So the m, remember, is the slope, and that's what we're focusing on here is when the slope is a fraction. Now, remember that a fraction is just like this with a number a in the numerator, that's the top, and a number b in the denominator. And really it's a division as well. And we can think of any number, a whole number, as 5 over 1. And that's perfectly okay. Similarly, negative 11 could be negative 11 over 1. So notice that that negative goes into the numerator. Or it could be 11 over negative 1. So that negative went into the denominator. Or the negative could be out front, and it could be negative, and then the fraction 11 over 1. It could not be, this would not be true, negative 11 over negative 1, because this would be a positive 11. Okay? So here, as I said before, the slope, we think of it as rise over run, change in y over change in x, and delta y over delta x. And we can always calculate slope by looking at 2 points. So for instance, I can look at these 2 points right here. And the points are the places where the line, here's our line, crosses the corner of 2 grid lines. So these are corners of the grid lines. This is not a corner of a grid line. You can see the corners of the grid lines are right there. Okay. Now, if I use those 2 points, and I'm going to zoom in here for a moment. I'm going to zoom in on that. I can think of, here's my delta x. Delta x equals 1. Here's my delta y. Delta y equals, let's see, I go up 1, 2, 3. So my delta y is 3. So there, I can see that my slope is delta y over delta x, 3 over 1. However, I can use any 2 points to calculate the slope of a line. I can use this point and this point. And if I do that, there my delta x is 2. I've gone 2 to the right. Whoops. And my delta y is up 1, 2, 3, 4, 5, 6. So my delta y is 6. So here my delta y over delta x is 6 over 2, which also equals 3. So notice this equals 3 and this equals 3. So they're the same value even though they look different. Okay? I do want you to see one more way that we can think about it. If we go from this point down to that point, so we're starting at the point on the right. Actually, let me do this. I'll do from this one to this one. So we're going this way. That would be a delta x of negative 2 because we're going to the left, and a delta y of negative 6 because we went down. So our delta y over delta x would be negative 6 over negative 2, which also equals 3. So it doesn't matter which point you start from. If you start down here and go up to there, or start up here and go down to there, but it will notice that they are negatives here and positives there. Did anyone see something new about slopes and fractions right there? Anything they haven't seen, or maybe they were reminded of it? But that's all just a good old-fashioned review. All right. Questions? Okay. On this one, we're going to go from the orange to the black. So I'm going to zoom in here. My delta x is 2. I've gone to the right 2. And my delta y is 1. I've gone up 1. So that means my delta y over delta x is 1 over 2. Now we're going to go from the blue to the black. So my delta x is negative 2, and my delta y is negative 1. So 1/2 should equal negative 1 over negative 2, and that is true. We could also represent our slope as 0.5. That would be okay as well. But it is nice to keep it in fraction form because then we can see our delta y over our delta x. So from here, up 1, right 2, up 1, right 2, up 1, right 2. Okay. We don't usually write it this way, but it's perfectly okay. Down 1 to the left 2, down 1 to the left 2. Questions there? All right. I want you to look at this and see if you can figure out the slope. I'm going to give you a moment to investigate that and try to figure out the slope. Go from the orange to the black. Does anyone want to volunteer? Elisha, yeah? What's our delta y? And what's our delta x? So our slope, you're suggesting, our slope would equal delta y over delta x, which is great. Yeah, awesome. And now, if we look at going from the blue to the black dot, our delta y and our delta x. Anyone willing to volunteer ideas here? What is our delta y as we go from here up? Anybody? Delta y there? Yep. And our delta x? Negative 4. So here, this could also be thought of as up 3 to the left 4. So notice our numerator tells us up or down. Up is positive, down is negative. Our denominator tells us left or right. Left is negative, right is positive. Any questions there? All right, that's the end of the video for today. I hope it was helpful.